All right, and we're back with another chemistry video. This time we're going to talk about the periodic table of elements. You're looking at the first screen here. Top left screen, you can see the periodic table. At this point, you're probably noticing a couple of things. You're noticing, and pay attention to my mouse. You'll notice that it's shaped kind of funny. You have these elements down here that seem to be pointing this direction, and then you have these groups over on this side that have more elements in them than these groups down here, and then you have these groups over here, and then there's this dark stair step. We're going to get into that here today, and then next video we will break apart the periodic table as far as and differentiate between metals, nonmetals, and metalloids. So here we go. We have silicone here. You can see the symbol is capital S lower I. So this is a very important piece that I'm about to tell you. Number one is the capital. If you have two letters, the first letter is the one that's capital. The second one is always going to be lowercase. So make sure you understand that. It's a great way to also figure out how many elements might be in a compound, which we'll talk about that at a later date. But again, for carbon, it's just capital letter C. But for chlorine, it's capital letter C, lowercase l. So just pay attention to that. Here you have capital S, lower I, that's silicone. Its atomic number is 14. Remember when we go to ape, if you know one, you know it all. So if you know the atomic number is 14, you know that it has 14 protons and 14 electrons. And then down below, you can't see it very well with on this screen, but that mass is 28.086. We round in middle school as far as mass is concerned, so that mass would be 28. So if you're using the MAN strategy, you take the mass, which is 28, you minus the 14, and that gives you 14 neutrons. All right, moving on to the next slide. Periodic table is a list of all known elements, each element made from a different type of atom, and the table is arranged based on the structures of these atoms. Pretty self-explanatory. There's two, we use table salt, sodium. If you know the elements that are in there, it's Na and Cl. It's sodium and chlorine. If you were to ingest sodium by itself, you would die. If you would ingest chlorine by itself, you would die. But because those two come together and make a compound, it neutralizes those effects on the human body, and we can ingest some levels of salt. Sodium, if we ingest too much, it's not good for our health. Because our body, there's certain elements and certain things that we eat can mess up our bodies in a lot of ways. If you notice, in the last 100 years, you think about it like this: we're humans, been on the planet for a hot minute now, thousands of years, and our diet has changed dramatically in the last 100. Whereas the thousands of years before that, humans ate the same thing. And if you think about science, you think about how adaptation is concerned and that type of stuff. So when you consider the fact that our diet has changed in the last 100 years, it's no wonder why people are dying of cancer and all this other stuff. So it's important to know what you're putting in your body. If you're eating a bunch of Takis or chips with whatever, look on the back, look at the label. If you don't understand what any of that stuff means, that means that it's chemically treated and it's probably not good for you if you have a lot of it. So, I'm trying to make more help mold more responsible humans on this planet. You do you. If you want to eat a bunch of Takis, go ahead. Just know what it's doing to your body. Anyway, moving along. Next slide. Elements are in order of atomic number. You probably have known that. Number 1 on the periodic table is hydrogen. Number 2 is helium. Number 3 is lithium. And it kind of goes on and on. So, and that you can go and it goes like you read a book from top to bottom, left to right. 1, 2, and then we have 3 all the way through 10. And I'll explain all this later, but when you're looking at the periodic table, you can look at those numbers, those atomic numbers, and you can see what's happening there. And so the one thing that you can deduct from looking at those atomic numbers is, boy, so hydrogen does have 1 proton. Helium does have 2 protons. Lithium does have 3 protons, and so on and so forth. Once you understand the periodic table, it can really give you a lot of information, and all the information is looking at you. It's all right there on the periodic table. So looking at the number of protons is how you identify an element. Moving on. Atoms have the same number of protons and electrons. Yes, that is true. But I will be, introducing the fact that electrons can be gained, lost, or shared when elements go through a combining, which we call a compound. When they make a compound, they do kind of share some of those electrons. You have some groups on the periodic table are more reactive than other groups. So that information is coming to you now, but for just to let you know, be ready, because sometimes those electrons can change a little bit. But I wanted you to know, as long as you have neutral atoms, we know that APE is in full effect, and if you have 13 protons, you also have 13 electrons. But they can be shared if they undergo chemical reaction. Electrons are arranged around the nucleus into energy levels. The nuclei is in the middle, which is the nucleus, of course, and it has protons and neutrons. And both of those weigh 1 AMU. So AMU is just how they say the weight of these particles. So if you have 7 particles in your nucleus, you know that your atom weighs 7. That's how that works. And each energy level is shown with a circle and with black dots for the electrons. At this point, this is a great screen to kind of tell you how the electrons will fall on those energy levels. It's the rule of 288. So as you're looking at your periodic table, you look at the top row, again going all the way across. There's only 2 in there. There's going to be hydrogen and there's going to be helium. There's only 2 in the first row. And so that row only has 1 orbital or energy level, and that's all it needs. So the helium has 2 electrons in the outer orbital, and hydrogen has 1 electron in that orbital as well. So that's pretty basic. But then you move on to the second row or period on the periodic table, and that starts with lithium. And now you can see that element has 2 electrons in the inner orbital, and now with that second orbital on the outside, it's going to have 1 electron in that one for a total of 3. So lithium has 3 protons and 3 total electrons. 2 electrons on the inner orbital, 1 electron on that outer orbital. Great question right now is, as you're looking at the screen and you're seeing this Bohr diagram of a mystery atom, what atom do you think this is? So how you would do that is you would count either the electrons or the protons. The protons are identified in the nucleus with the plus because they're positive. And so you have 1, 2, 3, 4, 5, 6. So this mystery element is number 6 on the periodic table, which happens to be carbon. So we're going to move on to the next screen here. Rows on the periodic table are called periods. And you can see there's a great image that has it color-coded kind of like a rainbow. Row 1, hydrogen and helium. Row 2 is lithium all the way to neon. And row 3 is sodium all the way to argon. I'm going to challenge you to memorize those 18. The reason why is because it will help you with all of your chemistry questions from here all the way to the end of the school year. So knowing that it goes hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, just knowing those in order will help you a ton. So I recommend that you definitely do that. So you have row 1 going across with just 2 elements in it, row 2 with 8 elements, and row 3 with 8 elements. Those are the 3 rows that I need you to know. The rest of them, you don't need to necessarily know where they are. You just need to know how to identify and find them. So if I tell you what element is number 22 on the periodic table, then you just go down and you look for the atomic numbers and you find number 22, and it is, I believe that's titanium. So just being able to find that and then being able to ape man, capital T lower I, which is titanium, on the periodic table. If you can ape man that, that's all you need to be able to do. Know that it is in row 4 and that, it's number 22 on the periodic table, and its mass is 47.8. So we round up to 48. And so we take that mass, we subtract 22, and that tells us how many neutrons it has. All of the elements in the same row have the same number of energy levels. Very true. I already talked about that initially with hydrogen and helium. It only has one orbital or one energy level. Row 2 has 2 energy levels. Row 3 has 3 energy levels, so on and so forth. And then I also talked about the rule of 288. How many elements are in the first row? 2. How many are in the second row? 8. How many are in the third row? 8. So by doing these board diagrams, as you can see below that picture of the periodic table, now it should make a little bit more sense. You can actually see the board diagram for each one of those elements. Lithium, beryllium, boron, so on and so forth. You can see all the board diagrams already drawn out for those elements. Very cool and good information, and you will be definitely using that very, very soon. One of the cheat sheets on the periodic table is, if I was to ask you, what row is magnesium in? Well, the number is right next to it. You can see it's in row 3. And if you look up top, above magnesium, you will see that it's in group 2. So I could say what element is in row 3 and group 2, you'll be able to say that is magnesium. You can see right here, row 3, group 2, magnesium. What element is in period 5, row 6? So let's check that out. And here's a great distractor right here. As we are learning the periodic table, this group of elements right here, the ones that I'm circling, these are called the transition metals, and they are not considered when we were talking about groups on the periodic table. That does not mean that they aren't very important elements. They most definitely are. Zinc, nickel, iron, they're huge. I mean, these are big time elements. Silver, gold, mercury. We call these the transition metals. They do not react like other elements on the periodic table. So when we're talking about reactivity, and for everything you need to know for middle school science as far as reactivity is concerned, this group of elements that I keep circling for you, we ignore. That does not mean you won't have a question on them, but it's going to be a basic question. Something like, what element has 47 protons and reacts like copper, or reacts like silver, or whatever, reacts like copper? You can look for the one that's number 47 and you would say silver because it's right below it. And so, it reacts like does not necessarily mean that it reacts. It could be non-reactive. So yes, silver would react like copper. It won't react. Their reactivity would be the same in this instance. So the groups and so we have these groups that go up and down. They're called, that's how reactivity is determined. And so we have group 1, group 2, group 3, 4, group 5, 6, 7, and 8. Don't get confused by the 13, 14, 15, 16, 17, and 18. Because if you think about it, that's how many actual groups there are. But when we're talking about reactivity, and for everything you need to know this year in 8th grade, we ignore these. And for that sake, it's group 1, 2, 3, 4, 5, 6, 7, and then finally group 8. So these rows that go left to right, they really don't mean anything. All it tells us, the only information you can deduct from the rows is how many orbitals those elements have. So all of these elements here in row 6 have 6 orbitals. And that's all you need to know about that. Moving on. Columns on the periodic table are called groups. So that's an introduction to my acronym GFC. Maybe you've heard of Good Fast Chicken or something like that. It's kind of like my way of remembering that GFC, it all means the same thing. It's the groups on the periodic table goes up and down. But the test likes to say columns, sometimes likes to say families, but it does go up and down. So this is all the elements in group 1. Hydrogen, lithium, sodium, so on and so forth. And they all have the same number of valence electrons. Remember from the other video, valence electrons means how many electrons are in the outer orbital. So potassium here has 1 valence electron, but 19 total electrons. You need to be able to differentiate between that. Already talked about this. We don't worry about that. Bye, y'all. We don't really worry about that. We know that this is group 1, 2, 3, 4, 5, 6, 7, and 8. Elements in the same group have similar physical and chemical properties. We're going to talk about these properties when we go over and differentiate between metals, nonmetals, and metalloids. That brings us to group 8. They are stable. Their valence shell is full. So that outer orbital is full, follows the 288 rule. So helium has 2 in its outer orbital. It is stable. Neon has 10 in its outer orbital. It has 8 in its outer orbital, 2 in the inner orbital. So it has 8 valence electrons. It is stable. And then argon has 18 total electrons, but 8 in its outer orbital, making it stable. Group 1 is the most reactive metals. They're a very reactive group, the most reactive metals. Group 1, 1 valence electron, 1 electron they want to give away when they combine with another element, particularly group 7, and I'll explain that in a minute. And here we go. Group 7, or 17, is the most reactive nonmetal group because they need to only gain 1. They are 1 valence electron away from being full and being stable. So that's why Na over here and Cl combine to form sodium, which is table salt. Group 18 already has 8 valence electrons. They are the least reactive group on the periodic table. They do not play well with others. They are noble. They don't mess with the other peasants, the other elements on the periodic table. They do not need to combine, and they won't. They are non-reactive, also known as least reactive group on the periodic table. So, why is helium a noble gas if it only has 2 electrons? Because its outer orbital is full. Because we know that the first row can only hold 2 electrons. And this makes it an unreactive noble gas. All right, guys, next time we talk, we'll talk about the difference between metals, nonmetals, and metalloids.